My name is Adam Buckner, and welcome to our ongoing series of live training sessions. Tonight's class is going to be an introduction to Unity and the Unity editor from a 2D perspective. And in this class, we're going to cover what the Unity editor is, how to navigate and work in the editor, know what game objects and components are, look at the game object component pattern, and also look at the basics of 2D scenes, including things like sorting layer and order in layer, so that we can order our 2D sprites in the scene. So let's talk about what Unity does. What does Unity do? Unity creates interactive applications for many platforms. Now, Unity is primarily a tool for creating games, that is true, but Unity creates many non-game applications, including interfaces and sims and sims and other applications. People can use them for architectural walkthroughs. There have been people using Unity for teaching aids. There are some companies that use Unity simply as an interface, and a touch interface for controlling other applications. Let's take a look at our gallery. How about that? And let's take a look at this is the Unity website. Let's go ahead and take a look at the showcase. And if we can go ahead and look at the showcase, and we'll come down to Made with Unity. And we can see that there's a ton of different types of games that have been made with Unity. It's definitely worth a scroll through on the website of just sort of seeing all of the different and fantastic games that have been made. That have been made in 2D, that have been made in 3D, that have been made in 2.5D orthographic, vector graphics games as well. So we can use Unity in many, many different ways. And I think it's important to note that that Unity is not a repurposed game engine. It's a game engine that's been created from the ground up so that you can make any sort of game that you want. You're not limited to any pre-decided or pre-configured type of game. And also, Unity is multi-platform. I think that's important to look at. Unity is multi-platform. Unity can build and deploy to many platforms, including Mac OS, Linux, Windows Phone, iOS, Web, Android, BlackBerry, and also on consoles. We can, with licenses, you need licenses both from Unity and from the console developers in most cases. Xbox One, Xbox 360, PlayStation 3, 4, and Vita, PlayStation Mobile, Wii U. So if you have any questions on that, as it says down here, contact your Unity sales team. Just realize that Unity is a very versatile platform. You can make any type of game that you want, and you can deploy it to many, many different types of platforms. But today we're going to be looking specifically at 2D. We're going to be approaching the Unity editor as if you hadn't seen it before, and approaching it from a 2D perspective. So to see this in action, let's create a new project. So I'm going to bring up Unity, and we're going to go through the process of creating a new project. There we go. The new release of 4.5, which was today. And so we're going to create a new project. We can do that by coming up to the File menu and hitting New Project. What we want to do here is create a 2D project, and we can do that by setting up the defaults down here. We have the choice of setting up defaults for 3D or setting up defaults for the 2D project. And so we're going to go ahead and pick 2D project, and then we're going to set the path. And I'm going to just set that to my desktop, and I'm going to call this, I've already got Intro to 2D, which is where I started, so let me say Introduction to Unity. How about that? Introduction to Unity. And so if we look at the desktop now, we don't see this. There's the intro to 2D that we've started from. The new one that we're making hasn't appeared yet, and that's because we haven't created any of the files. And when we go ahead and hit Create Project, we will see what it appears that Unity has closed down. And actually, Unity hasn't closed down. Unity has simply closed our previous project. Now it has written the files, and then it opens up those new files into the project window. So we now see that we have an introduction to Unity here on our desktop. So when we pick that 2D setups where we do we set up our defaults for 2D, it does two things. It sets our scene view into 2D rather than in 3D. The default for Unity is the 3D mode, where we can look around in 3D space. But when we set our settings for 2D, we're going to be locked in an orthographic space here in 2D, where we're looking at the XY plane, and then we're going to be looking down the Z axis. And the other difference it makes, the other change it makes, if we go here to Project Settings, Editor, we'll see that it has set the default behavior mode for 2D. And these can be changed at any time. You can change the default behavior mode anytime during your project. It just simply is how the editor is going to behave. You can also change this 2D scene view at any time. But when you have the default editor mode for 2D, it does two important things. One is when you create a new scene, we can see we have a new camera here, it makes sure that we have an orthographic camera. In 3D, we want a perspective camera where we have our frustum, which, of course, is larger the farther you get away from camera. So it gives us that sense of perspective. Whereas if we've got the orthographic camera, there is no perspective, which is the usual camera for working on a 2D project. The other thing that it does is that when we import our sprites, import our sprite objects, which I'm going to do, whoops, I've cleared them off my desktop. Sorry about that. Let me just quickly put those back. Sprites, yay. So let's do that. So if we import our sprites by putting them into the project view, and they come in, then we can see our sprites have been imported as the sprite type, rather than as a texture type. So that's the primary difference about setting up for 2D, because now we have both our project and we have our scene view set up to work with 2D. Now, when we first get started with a project, we're going to need assets. So we can either create our own assets or we can get them from other sources. Now, the best place that I would suggest that we get assets from is the asset store. And we can get to the asset store by going to the Windows menu and selecting Asset Store, or hitting Command or Control 9, depending upon what platform you're working on. Now, the asset store is where Unity distributes assets and distributes its own assets. So Unity Technologies will distribute their own assets. Our demo projects all come through the asset store. The asset store is also a very good place to get things like models and animation and sounds, and also a very good place to get scripts and editor extensions. And I think that is very, very important, because when you're creating a project, you may find something that you need to solve, whether it's a system, you need vector graphics, or whether you're looking for bone animation, you're looking for a way to keep track of an inventory. You can come to the asset store and you can find that people have created scripts or editor extensions that can solve your problem. In our case, we're going to go ahead and take a look at the demo project, the Unity projects, the 2D platformer, and we're going to be using this as part of what we use to describe the editor today. So I'm going to go ahead and import that. Since this is free, all you can simply do is import, and we can see that it's going to decompress that package and it's going to import it in another window. There we go. It's going to import this directly into our scene. Let me bring that window over. There we go. So these are all of the assets that are in the asset package that I've just downloaded from the asset store. And I can choose which ones of these, which assets I import by selecting the tick boxes. I can select all or none. And I can also, when I'm done selecting the assets that I want, I can select import. Let me go ahead and clear away the asset store window once it's done importing. We're bringing in all of the images. We're bringing in all of the scripts. We're bringing in all of the information, all of the assets that we want for this completed project. We've now imported our project, and that has the scene in the scene view in the scenes folder here. So I'm going to go ahead and load this up. I'm not saving. I've done nothing to this scene. There's no need to save it. And this is going to go ahead and open our demo scene here, the 2D platformer. Now, when Unity is working, there are a series of windows or views that we have in the Unity editor. Each has a different function, and we use this series of windows and views to be able to create our game and gameplay. Now, I'm going to go over very briefly each one of the windows, and then I'll come back and cover them in detail. First and foremost, the project window. Project window down here is where we store and import our assets. Then there is the hierarchy view, which we have up here, and the hierarchy view is where we see a list of the objects in our scene. Then there's the scene view over here, and the scene view is where we work on our objects in the scene space. Then there's the game view down here, and the game view down here is where we can play and test our game from the game view camera. And then what I have docked back here is the console. Cool. All right, let's clear that. So the console, if we don't have the console docked, and we can talk about docking in just a minute. If it is not open, we can go to Windows and we can open it from the Windows menu as console, or it is Shift Command or Shift Control C, and that will go ahead and bring up the console in our editor. Just go ahead and bring this in. It's partly on I've got multiple monitors running here today, so that was partly over on this monitor. Now, if you don't want to leave it floating, which can be a problem because you click on the main menu and then we find it disappears, you can go ahead and dock the console. You can see that it's dockable. We can rearrange and dockable. All of these windows are rearrangeable and dockable, and we can talk about that in a little bit more detail later. And we can save our layouts. So now let's go into these in detail. Let's talk about the project view. This is the project view down here. Now, the project view is a view into our project's assets directory. And this is where the developer can import and store and organize their assets. Assets are imported objects from other sources like sprite images or sprite sheets, animations, and sounds, or they can be created directly inside Unity like prefabs and scripts and materials. We can create new assets from the pull-down menu. There's a create menu here. So we can create new scripts, new prefabs, new materials, new controllers for animation, new physics materials. And that's the same as coming up to here and hitting Assets, Create. And we'll find in general that there is a menu option, and then there will be an internal menu in the windows inside the editor. So this is the exact same menu, except it's up here under Assets, Create. One of the important things to note, however, is the project view is a view directly into the assets directory on our hard drive. If we pick any of these, and we pick Reveal in Finder, we can see that we are browsing onto the project on our desktop. So here's the project on our desktop, Introduction to Unity. And inside that, we have our library and our assets and our project settings. And inside the assets folder is where everything is being saved and stored. If we look at our assets directory here, let me close these windows down, and then we look at our assets here in the project window, we can see that they are identical. Let me sort this by name. So this project view is not owned by Unity. It's owned by our operating system. And this means there's some very specific issues that any developer needs to be aware of. You do not reorganize your assets directory from your desktop. So you do not rearrange, reorder, or rename the assets here in the assets directory from your operating system level. You can move assets into Unity when Unity is running, and those will be added to your project, but don't rename, reorganize, or delete them because it can confuse Unity. Now, Unity is smart, and Unity can pretty much try to figure out what you've done, but it's still not a good idea because of the way that it keeps track of the unique IDs for all of our assets. So make sure that if you need to reorganize, rename, or reorder anything, that you do that inside Unity with Unity running. Now, the hierarchy view up here works very closely with our scene. This is a view into the contents of our current scene. All of the objects in our scene are instances of our assets. They are instances of our assets from our project view, or they are instances of assets created directly into the scene using the Create menu, including primitive shapes, lights, and other assets, which you can create directly into your scene using the Create menu. That's also the same that you can do up here with Game Object and Create Other. So this is how you make instances of objects in your game. And what you see in the hierarchy is a list of all of those objects. Now, this is a hierarchical view. And it's used to define the organizational relationships between all of the objects in our scene. And as of 4.5, you can rearrange these game objects in any order that you choose. So you can just go ahead and pick up and move the order. It used to be that these were in alphabetical order, and you can organize it in alphabetical order with an editor script. But currently, you can go ahead and reorganize and reorder the hierarchy view in any order that you choose, based on moving the transforms around. Now, before we talk about the scene view, let's talk about what scenes are. Scenes are what one would usually think of as a level. Scenes can contain only one level, and many people feel one level per scene and one scene per level is correct. But that's not necessarily true. You can have multiple game levels in a scene. And also, scenes don't need to be included in your build, and you can simply use them for tests and experiments. The currently loaded scene will contain all of the assets, the sprites and animations and scripts controlling logic that are currently available and working in your game. And you can arrange these to give the player multiple game levels. I mean, I can imagine a game where if you, say, had a monster that wanted to eat some candy and it was suspended by some sort of hemp device, you could code it so that you could have multiple levels in one scene. And then have your players quickly have access to all of these different game levels. And then once you've exhausted a number of game levels, you could then reload a whole set of new levels by creating say a new box or a new jar of levels. And when they've completed the 25 or so levels that are in one scene, you could then transition to a new scene based on the code that you've written. So you don't necessarily need to have one scene for every level in your game, depending upon how you architect and how you build your game. You can have multiple game levels per scene. And then, as I said, scenes don't need to be included in the build. You can use them for tests, you can use them for experiments, and when you finally build your game, you only include the scenes that you want. So you can have many, many different scene files that are saved in your project, and you can choose whether or not you build them into your final game. Now, the scene view. The scene view is what allows the developer to see an overview of the game's current scene and the state of that scene. We use this view to move and manipulate our assets in our 2D, in this case, world, or 2D or 3D world. So you can pick game objects, and in the upper left we have a series of buttons, and they have hotkeys for them. Q will take us, oops, excuse me, I'm selecting my kill trigger there. Q will take us to the hand tool, and the hand tool allows us to move around in the 2D scene. Now, in 3D, you can also rotate your scene view camera. We can't do that because we're locked into a 2D perspective. If we remove the 2D scene, we can see, whoops, we're in 3D mode, and we can see all of our game there on the XY plane. And we can move it around. And I'm holding down the Alt key to do that, just so you know. So I'm using the Alt key as a rotate. But when we're in 2D mode, the Alt key simply is the same as being in the hand tool. Shortcut is Q, and we can pan around our 2D scene. The transform tool, the other transform tools, this is the translate tool. If we pick a game object, we can go ahead and move it around by its transform. Let's pick something a little bit more obvious. Let's take a tower. Tower. There we go. And we're moving that sprite around. If we click on the rotate tool, we're rotating that sprite. And if we click on the scale tool, we're scaling that sprite. And if we pick a handle, we're scaling it along an axis. If we pick it from the center point, we're scaling it uniformly along all axes. Same with the translate tool to a degree. But we've got a sprite selected, so we've got the sprite border. When we've got a sprite selected, we have the sprite outline, and we can now both scale and move and rotate. When we have a sprite in the scene, if you simply grab the sprite from any point, we can translate it. If you grab the sprite from a corner or along an edge, we will scale it. If you hold down the Shift key, we can scale it unevenly. We can search our hierarchy with a search box, and this will also affect our scene view. So if we were to search for our hero, we type in HER for the beginning of our hero, and we can see that everything grays out except for our hero. I'm going to go ahead and select him, and F for frame selected, and zoom in so we can see our hero there. So we can also find individual objects in our scene by manipulating the search of our hierarchy. Because remember that the hierarchy view and the scene view work very closely together. All of the objects in our scene in list view, I'm going to clear that, and these are all of our objects in the scene visible to us and be able to manipulate them. So the inspector view. When we search for something like, say, our hero, and we have him selected. Oops, come back here, hero. Hero, please. And there he is in our scene view. If we look at the inspector view, we can see all of the details of that particular game object. This view allows the developer to see an overview of the entire game object and all of the components on that game object. And it allows us to see and manipulate the exposed values on the properties of those components. Now, let's have a brief chat about game objects and components. What the heck are game objects? Game objects are holders. Game objects are containers. Game objects hold components on them, and game objects can actually hold other game objects in them. And when a game object holds another game object inside that game object, a game object family is created. So if we take a look at anything that has got a pull down, that is a game object, in this case foregrounds, holding a series of other game objects as children. So when you add one game object to another game object, you create what is called a game object family. And those that are above in the hierarchy are parents, and those that are below are children. And this can be many, many, many tiers deep as you need it for your game. Now, game object families can be used for two main purposes: mechanical purposes and organizational purposes. If you have things like the hero, let's take a look at the hero, which is a parent game object with a bunch of child game objects underneath. We've got, let me move this, let's move our tower out of the way. Oh, go away, Mr. Tower. There we go. And zoom back in on our hero there. So we've got the bazooka and the hat and the left and eye foot. All of these are sprites that we're using to make up our character. And for mechanical purposes, as we move the main character around, all of its bits move with it. But if you also look here at the foregrounds, we are using game objects for organizational purposes. There are no components on this game object. The only thing it has is its base transform and its header. And we are using this for organizational purposes in the editor to hold all of these children so that we can close it down when we need to. And we have a very compact, neat hierarchy. If we need to get to the foregrounds, we can open that up and we can see the children inside. So like a folder or directory, you can use empty game objects for organizational purposes, or you can use them, as we've seen with our character, for mechanical purposes. And what's important about this and why it works so well is the transforms of a child are directly related to the transforms of its immediate parent. So if we look at the bazooka, it has a position that is just off center. And if we were to zero these out, and remember we can do this with our context sensitive gear menu up here. I can reset this to 0. I'm going to change it. Boop. This also changes our scale. So let me undo that and let's reset the position only, because you can reset these separately. And we can see that that has moved in relationship to the parent. But when we move the parent game object, that bazooka stays in that exact same position. Let's put that bazooka back. Now in the game view is down here. The game view is where the developer can play and test their game. We can go ahead and hit play. We're not going to get any sound, unfortunately, because I don't have that. I don't think I've rigged that up to get you sound from the game. And here we can play. We can also pause the game, and we can step through the game. Let me zoom that up for you. You can step through the game one frame at a time. And if you want it to be maximized on play, then you select the Maximize on Play button here. Otherwise, it will play in the existing window down here in the corner without Maximize on Play selected. And with Maximize on Play, it'll try to fill as much of the existing space as possible. When you're dealing with your game view, you can pick an aspect ratio. Aspect ratio button up here in the corner, so you can pick an aspect ratio in general, and this will scale up to whatever size you choose it to be. Or you can pick specific sizes. Here we have the standalone, and I've preset 2 just for a tablet and phone, and it's going to try to stay within that size. And we can see, sorry, because we have a bit of a compressed monitor today. Let me just detach this. There we go. So in tablet size there, we can see that it's now specifically set to that tablet size or the phone. So you can go ahead and set these. You can go ahead and hit the plus button, and you can create either a fixed resolution or an aspect ratio, and it will stick to that. And you can choose that from the drop-down menu. Now, speaking of this, what I'm doing here with our layouts, we can rearrange, we can redock, and we can save our layouts. So if we want to go ahead and change something, we can just pick it up by the tab and do it. One way that I like to work is I like to work in order where I've got my project as the first column, and my hierarchy as the second column, and the inspector as the last column. So I can go ahead and lay that out. If I want to have my console down at the bottom, and then I want to have my game and scene next to each other, I can just go ahead and rearrange those. Let's say I'm working on my phone, set that up for the phone size of 640 by 480, whatever works for your monitor, and then I can go up to the layout menu and I can save this layout. This will pop up a quick little window, and we can save this. If I saved over tutorials, it would save my tutorials layout, but let's call this the phone layout. And now I have phone layout in my list. And if I went and I made a change, I could pick another choice, and I could come back to my phone layout. Or I could make changes, and unless I save this layout, so I want to move something around for whatever particular reason, and then I want to return to it, I can simply pick phone layout again, and unless I save over it, it'll return to its last saved state. I'm going to return to tutorials. The console view. I think it's important to know the console view. This is the view where the developer can see and respond to errors and messages. Errors are listed when Unity encounters them, and Unity will put compile and runtime messages here, runtime errors here. The developer can also add lines to their scripting code to display as debug lines in the console. So you can either use debug.log or print, and you will see this in the console. Also, if you see an error, it'll put the most recent error in the footer. So let's go ahead and do something that's going to cause an error. Let's see if we can find something that has a reference. I don't know this one particularly well. Do we have a reference here? Character, there we go, to our controller. Let's make that none. I think this will break it. Yeah. And we can see that we have a warning in the console saying our animator has not been initialized. And then we can see that that warning is down here. And if we were playing our game and the console was either not visible or not even in the scene because we had the console closed, we can see that the most recent message is here in the footer. You can click on it and it will bring that console to the front. And let me go ahead and close that tab. If the console is not even docked anywhere, you can click on it and it will open that console, and then we could go ahead and we could dock that. So let's undo that. Let's put back, there we go. There's that character back there in the animator. Now, the game object component pattern. I want to look at the hero again. And if we look closely at the hero, Unity works by using game objects and their attached components. Gameplay is made by game objects and their components interacting with each other. If we look at the hero, we can see that the hero is a game object. And I want to show you what a basic game object is. If we create a new empty game object, it's going to come into our scene at the bottom as a game object. We can see that all new game objects simply have a header and a transform. Now, all game objects need to have a transform. They need to know where in the scene they exist. They need to have a position, a rotation, and a scale. So this is the one component that is on every game object, and it is also not removable. Here in the context menu, you usually can remove components. You do not have the option of removing the transform component. But if we compare that to our hero, we can see that there's the header, which includes whether it is active or not. Let me just come back to the scene view here and zoom in on our hero. You can double click on the game object to to make sure that you see the entire game object in the scene, or you can hit F for frame selected, so you can hold down click on the object, hover the mouse over the scene view, and hit F, and we'll focus in on that using frame selected. We can see that our hero has a header with its name, whether it is active. It's got an icon. We've got a tag and layer and other items that are in the header of the game object, and the transform, which tells us where it is in the scene, its position, its rotation, and scale. All of the rest of these components have been added by the person developing the game. And in this case, we have a written script, the player control script, which controls the player, including its movement force, its speed, max jump force, jump clips. There is a rigid body 2D. The rigid body 2D is part of the 2D physics engine. It's a component that comes with Unity, has been added to this game object. Same with the box collider 2D and the circle collider 2D. And if we come close in on these guys, we can see them. Let me actually turn off some of these things. I can see I'm using the active button to turn off the foreground and the background. That'll give us a look at just our hero. And what we can see, these green lines here, that's the circle collider here at the bottom, and then the box collider here at the top. Make that even bigger for you. So the green lines here are our two colliders. The animator is a component that is used to associate an animation controller with this object. And then again, more custom scripts, player health, lay bombs, written by the developer, and then an audio source component. I'm going to close those down. Notice also that as I close objects down, their gizmos disappear. So that's showing us where the audio sources are playing there in the scene. And then same with the colliders. If you reduce them, we're not turning them off. We're just collapsing that particular component. But we're saying if we don't want to see the component in the inspector, we also don't want to see its gizmo in the scene view. So it is all of these components on these game objects that create our game and gameplay. And we put components on our game objects. Our game objects are empty. They're empty holders, and they hold components, and then it's how those components act and react with each other that make our game. And we can write our own components using simple scripting. And we're not going to go into scripting today because there's more than enough information about scripting on our site. I do want to show one thing about scripting, however, that when we get into scripting that is useful, if there's something you want to find out about and you are in your script, you can simply select it, hold down the Control key on Windows, the Command key on Mac, and then hit the single quote button, and it will bring up the scripting reference for that particular object. Or if there's multiple things, because Rigid Body 2D has multiple choices, you get a list of all of the choices that have to do with Rigid Body 2D that are found in the search. One of the important things about our documentation, and our documentation has had a very big upgrade and facelift as of 4.5, is that you can look at the code snippets in either JavaScript, C# or Boo. And so when you first come to the scripting documentation, you should pick the scripting language that you are going to be working in. In my case, I'm going to be working in C#. So when I go ahead and look at an object, ooh, and this one doesn't have a snippet. So let's find something that does, like instantiate. And we can see that the code snippet here is in C#. If I chose JavaScript, then my code snippet is going to be, and my example code is going to be in JavaScript. Or I could choose Boo, which is our Python-like language. We can see that there's the sample in Boo. So it's Command or Control keys. Command on the Mac, Control on Windows, and then single quote. So back into MonoDevelop, if you want to find out about input or input get button down, hold down the Control key on Windows, the Command key on Mac, and then hit the single quote button. And that will pop up with the search. So when you're writing things, very important, you do get code completion. So if you're writing something, we'll just mimic it here. You know, if our input, and we can see we've got input, and then once we do that, we can see our different choices of input. But if you really want to look at the documentation for input, double-click Command on the Mac, Control on Windows, single quote, and you're in the documentation for input. Click on input, and there it is, the input system. including static variables, static functions, and you can follow them through for that information. So that's my quick introduction to Unity with 2D as the idea. I'm going to read chat, but under the assumption that I have not seen your question, why don't we go ahead and start questions now? And if no one has answered your question in the back, this will save me from back reading into the chat. Go ahead and just throw your questions out in the chat channel. But I'm going to try to wrap this up in the next 10 or 15 minutes. So Mart4, you're sort of saying that the functionality has changed a little bit now that we have to use the search box. I will say that it is a bit of a difference, because if there is something that you want rigid body 2D, there is that extra step where suddenly you have to pick it from a list of rigid body 2D rather than going to it directly. That is true. Costalidis, do you need a Mac to test iPhone input? As far as I am aware, you need a Mac to use iOS. And I believe that, as far as I'm aware, and I don't believe this has changed because it was when I was doing iOS development, yes, you needed to have the iPhone and the iPhone using Unity Remote to be able to test your iOS phone, and I believe you needed to have it as the build target. The build target needed to be iOS as well. But I know that they've made recent updates to the Unity Remote. As a matter of fact, there's a new version of it up on Google Play and the Apple App Store. So there's a new build that goes with 4.5 of the Unity Remote. Is there a recommended language for scripting? I know JavaScript, but I don't like how it's loosely typed, so I'm thinking of learning C#. C# is a good choice. Now, I have some strong opinions about the language. I do very much appreciate JavaScript, and I know many people, including myself, who came to Unity that started off using Unity's version of JavaScript or UnityScript, and then after having had some experience with Unity, moved on to C#. And there's certainly a steeper learning curve when you're learning a language to learning C# over Unity's version of JavaScript. However, C# is a very solid language. It's a very strong language. They've brought in a couple of the little bits of sugar, like you can now say var. So, you can say var my thing rather than having to put a type when you're, say, instantiating something. You can say for each var thing in my collection of things rather than having a type. So that's convenient. But if you're starting with a language and you're starting with Unity, sad to say, I'd probably suggest that you do start with C#. Very specific, Hybrid 25. How can I make mobile games scale while taking into account virtual buttons on the Android? Like something smooth that would work on multiple devices with various resolutions. Hold your breath for GUI in 4.6. There are a number of third-party UIs that do well. I know that both EasyGUI and NGUI, which I have used, and a couple of the other ones like DF, I think it's DFGUI, which I have not, have anchoring and scaling solutions. UGUI will also have them. It depends whether you want to invest in another UI solution this close to the rollout of UGUI. It also depends how long you can wait. I mean, if you've got a project that you need to ship today, I would certainly look at EasyGUI, NGUI, or DFGUI. I have not, or look at some of the other ones, because I can't really endorse any of them. But I have found that all of them, the ones that I've used, to be perfectly solid and have always solved my problems. And I've also been using UGUI in the beta and the alpha, and I'm very pleased with that as well. Are assets like classes in object-oriented programming? Hierarchy parent-child class is confusing me, since it sounds so but it's not really. It is a little bit. I mean, ultimately, all of that hierarchy, here this will date me, all of that hierarchy Felgercarb is code in the background. I mean, we're pushing it around here in the editor, and there is object-oriented stuff going on in the background, but it's not specifically and explicitly object-oriented. But I think it's best not to get too codey about the editor. People who have a lot of code experience can start to see the patterns that are going on in the editor, but I do like to think of the editor in a non-code way and just think of the associated objects as sort of physical objects and groups inside the editor. I've got this container called Hero. It's got a bunch of scripts on it. Inside it, it has a bunch of sprites. These are all sprites that are all making up the, there's the mustache. You know, this is a ground check transform. There's my body. and they all are lumped together in this envelope, and that allows me to move that around. I try not to put the two together and try to keep code on one side and my organization and the hierarchy on another. Steak Pinball is saying is that there are some things that are easier to do, delegates and some other things, in C# than Unity script, but Unity script is softer and easier to work with if you don't have a lot of coding experience. But again, I would say if you're new to Unity, you're starting Unity, and you're determined, I would say pick up C#. Somebody whose name is in green that I can barely read, Balaluka. When you're talking about testing in Viewport, are there any packages and differences between developing for iOS and Android? There are some minor differences. There are also some differences in the way that the devices work, back button being an example on Android. So you will need to do some custom tweaking between the two mobile platforms, but the majority of your work will carry over. Are there better ways to get values from other scripts than getComponent? Calzun, you should only be using getComponent to get a reference to that component, and you can get that reference in the editor by creating a public variable and associating it in the editor. And if you use getComponent, I would strongly suggest that you do it once when you either first need that reference or when the object starts is in its start or awake functions, or on enable. So either get it once very quickly when you're waking up or enabling the object, or get it once just before you need to use it, but you don't get it repeatedly because it takes resources to go ahead and grab that reference. But getComponent is to grab a reference, and you can do that by creating a public variable in your script and populating that in the editor. I see there's a lot of different ways to do a menu in a game, but I'd recommend me I'm assuming you mean generic design for mobile. That's really difficult because it really depends upon whether you want something to pop up, pop down, whether you just want it there. Clicking buttons in general is relatively simple in all of the UI choices that you have, whether it's on GUI, whether you're testing a GUI texture, or if you're using third-party like EasyGUI or NGUI. Frankly, I would start off with just designing it on paper or designing it in Photoshop to a template of your device, and then figure out how you want to code it. When you're looking at UIs, I'd look at the asset store. Command or Control 9. I would definitely say you need to do your research because there are a lot. Also be careful what you're getting. Some of them are the code, like DFGUI or EasyGUI or NGUI are the code for making a GUI, and some are the artwork for making UIs. They're the button artwork. They're the GUI style. So you just need to be careful that make sure that you're getting what you want. So do your proper research, read reviews, follow the websites, look at the stars. But certainly come to the asset store and look at UI, and most of them are going to be under Editor Extensions UI. Editor Extensions GUI, NGUI, Text Mesh Pro, Daikon Forge. So take a look through here, and you should be able to find some third-party UIs. But also be aware that soon as we can, we will have 4.6 with UGUI involved. Platform specifics of incorporating such things as high scores on Android. I'm presuming at this point you're talking about saving them to, say, a website for a leaderboard so that everyone can get it, rather than saving them specifically on one device. If you're simply saving them as one device, then I would suggest that you look at either Mike Geig's data class, which is in the live archive section about serializing information, or you can look at player prefs. It depends upon how important it is to you. Player prefs is very accessible and easy to edit, but it's a good place to start saving high scores, say locally for one player on a device in player prefs, or serialize it to a file, and Mike Geig covers that very well in his class, so you can look at that in the live training archives. Anyway, it's also a little bit after 9. I'm probably going to wrap up the audio part of this, and I'll stick around on chat for a little while longer. I also see that Will's still in chat. I've answered a bunch of questions, and I'm sure I could keep on answering them all night long. Thanks for coming. And so if you have any questions that we didn't answer here, go ahead and follow us at Unity3D and at Mike Geig and at Will Goldstone. Thank you, Will, for moderating today. And at the Ant Ranch, which is me, Adam Buckner. You can check out the forums, and you can check out answers if there's something that we haven't answered. So thank you for coming, and maybe I'll see you again next week. Thank you very much.